This is a short introduction about the regression analysis and multiple regression. We did talk in previous lecture in the classroom about the simple linear regression. As I told you, when we talk about regression, we are thinking about prediction. This is another example here that we have in for simple linear regression. As you remember, one of the assumptions is both of the variables should be continuous variables. In this example, we have a variable which is the number of cigarettes smoked per day, as you see here, from 0. And then we have the other continuous variable, which is the mortality rate based on 10,000 per year. And we have the numbers here. And then in the research that when they are calculate this number of cigarettes and for the mortality, they found the result something like this blue line here, which is pretty close to a linear positive correlation between these two variables. So we actually can say that if we assume that the number of cigarettes smoked and is an independent variable and the mortality rate is a dependent variable, which is our assumption, or maybe it's come from the previous studies, then we can say we want to predict the mortality rate, which is our dependent variable, based on the just one variable, which is independent here, is the number of cigarettes smoked per day. So we cannot use this line directly because there is no formula that we can use for this line, but we can replace it with a straight line, which is pretty close to the blue line, and we call this line a regression line or prediction line. And then we can use this line, because we can have a formula for that one, to predict the mortality based on the number of cigarettes smoked per day. The formula, as we explained, we can have it from the SPSS that we calculate, and then as you see, y here is in this axis, is the dependent variable that we want to predict, and x is the fact or the independent variable that we can have. For example, if you ask someone about the number of cigarettes per day and say 20, and then we can use the regression line and then find the number on the mortality rate, which is 6.8 per 10,000 per year. So this one was a simple linear regression. Let's put it in a more visual way and imagine that if you have your pool table, a billiard or something, and then your goal is to have the white marble in this hole in this corner, and then you have 3 possibilities and you want to choose one of those as the best shot to reach to this goal. So we can say that this white marble is our dependent variable and the other color marbles are our independent variable. We should want to choose one of them, and there is possible to guess, but the possibility to reach the goal is less. For example, for the variable number 1 here is a little bit more possible with variable number 2. Variable number 3 is the best maybe shot that we have. If we want to talk statistically, we can say that maybe the R in Pearson R, which is show the strength of the linear correlation, is the strongest here. So what we have here is the prediction of between 1, 2, and 3, and we want to say that number 3 give us the best prediction to reach our goal. So in this case, we can use the variable number 3 to predict the goal regarding the dependent variable, to guess this one. Now, in a more complicated situation, maybe we have a bunch of variables, independent variables, and we cannot choose just one of them to have this shot. So we need to choose a group of variable for this prediction. And if we want to do it, for example, here, and we can see the variable number 6 is maybe the best shot and possibility to reach to this goal, but it's not possible to use only this variable. And we can see that the variable number 3 may be the best hit to direct the variable 6 there. But this one is also is a shot that we should calculate variable number and 2 because they are in the way here. So we should have a calculation that if variable 3 passing through and have the variable 1 and 2 and then hit the variable 6, then it's possible to have the best shot here. So this group of variables that we have here, we call it a model for prediction because we are including all of them, and not all of them have the same effects for this line to the goal. Some of them have a maybe more strong effect here that we should find out which one, as here we said, for example, variable 3 also is very important. Some of them has a less effect on this movement to have this prediction on the goal, that we call this one the model for prediction. And in SPSS we can find the contribution of the variables, the level of contribution, that which one has a better or higher level of contribution for this prediction. I also go through another visual example here to go a little bit more clear. Imagine that there is an accident happening. And then the guy who had this accident, the wife come and say, okay, what happened? And he is saying, okay, why the sun blinded me? This is not the only reason, the wife says. What else you did that you had this accident? And then says, okay, you know, these days I have a lot of problem in my head, and maybe the economic problems weakened my concentration. No, maybe that's only this one. What else you did? Say, I was looking at my mobile also. So all these together, we cannot say that this is just one variable which affect this accident, but all of them together can cause this accident. So the accident is the effect or dependent variable here. And we have here our independent variables. This is the causes actually. So the combination of all these independent variables is supposed to be a model for prediction of the outcome or accident. But the effect of those variables are not the same. For example, looking at the mobile maybe has the biggest effect on this accident. So the contribution of the independent variables is different, and we want to find out a model that include all of these problems to answer to find out the regression, to find out the outcome of this model. And we use the regression analysis to find this one. But remember, not all the causes, this is what we choose to put in a model. A model is not necessarily a correct model. And sometimes there are something that the model is not included in, but there is actually one of the major causes. So the model is changeable. And here, for example, he is thinking, okay, I cannot mention the hitchhiker who dragged my attention, which was probably has a big effect. So the model here maybe answers somehow for prediction for the next time the accident, but we should think about that the variables that are not included. So if we look at the dependent variable, there is two possibilities for this dependent variable. It's either a dichotomous categorical or it's a continuous variable. Dichotomous categorical, for example, if someone is sick, yes or no, or the outcome is the accident, yes or no. And the continuous variable is also like the mortality rate that we had an example in the simple linear regression. The mortality rate was a continuous variable. So if we have a dichotomous variable here, we use the multiple logistic regression. And for example, accident, yes and no. And then we have other independent variables for this one. Then we use the logistic. So the one that we decide which type of regression analysis we use is the dependent variable. And if it's a continuous variable, then we have a linear regression analysis to do. So based on those, we can choose the type of the analysis that we have. In your example, you had a questionnaire with the 9 questions that we add more variables also. Imagine that the infant birth weight is your dependent variable. If you choose it as a continuous variable, as a weight based on the grams that we had, then you are going to use the linear regression. But we dichotomize this one to low birth weight, yes and no. If we use this dependent variable as a dichotomous variable, then we should choose the logistic regression for the prediction. And maybe this one make more sense in this example, because the dichotomous variable here is for prediction if the baby is low birth weight or not. So the rest of the variables here are independent variables, and we not necessarily use all of them in a model, but we can find a very good model in this case to find these independent variables, which of them is the best for prediction of the low birth weight here. So the question number 1 here is in the center, and we have other questions for prediction, but the effect of other questions are not necessarily the same. Some of them maybe has a very higher effect or contribute more in the prediction, and the other maybe less. This is what we are going to find in a regression analysis. So this is a model, and this model is also useful for controlling the confounding factor sometimes.